Lesson 10.3, Experimental Probability, Examples 4 and 5. Experimental probability. Sometimes it is not possible or convenient to find the theoretical probability of an event. In such cases, you may be able to calculate an experimental probability by performing an experiment, conducting a survey, or looking at the history of an event. Experimental probability of an event is given by the number of trials where A occurs over the total number of trials. Example number 4. The bar graph shows how old adults in a survey would choose to be if they could choose any age. Find the experimental probability that a randomly selected adult would prefer to be at least 40 years of age. So the probability of event A occurring, we have to look at how many adults would have a desired age of at least 40. So when we do that, we're looking at 551 plus 300 plus 238. When we add those up, the desired age of 40 or greater, there's 1,089 adults who would prefer that, over the total number of adults surveyed when you add them all up, 3,516. So the probability of an adult choosing a desired age of 40 or greater is about 0.31 or 31%. Number 5, you throw a dart at the square board shown. Your dart is equally likely to hit any point inside the board. Are you more likely to get 10 points or 0 points? So we first have to look at the probabilities. The probability of getting 10 points is going to equal we have to look at the areas. The area of the 10-point circle over the area in total. So when we look at the area of the 10-point circle, we see a radius of 3, so it would be pi r squared, or 9 pi, since that radius is 3. The total area of the entire board, since it's a square, is going to be 18 by 18. A side squared, 18 by 18. So it'll be 18 squared, and when I do that math, the probability of getting the 10-point circle is approximately 0.0873. The probability of hitting 0 points, which is that black area around the outside, we have to take the area of the entire board, which we know to be 18 squared, and subtract the area of the largest circle. And that area is going to be, or that radius for that largest circle is going to be 9 inches. So that'll be pi r squared again. And since r will be 9 for that largest circle, it'll be 81 pi over the total area of the entire board again, which we know to be 18 squared. So when we do all that math, remembering to do the numerator first, we get about 0.215, or 21.5%. You are more likely to get 0 points by hitting one of those corners than you are to get the 10 points in the center.